Okay, and students, last class we solved some problem on capacitance gradient. And today we'll solve a problem numerical on intersheet grading. Okay, let us take an example. A single core cable has a conductor of diameter 2.5 centimeter and a sheath of inside diameter 6 centimeter. Okay. Calculate the maximum stress. It is required to reduce the maximum stress by using two intersheets. Find their best position, maximum stress, and the voltage on each system. Voltage is 66 kilovolts, 3-phase. Okay, it has been asked for 6 marks. See here. A single core cable has a conductor of diameter 2.5 centimeter. So what is this? Small d, right? Small d, 2.5 centimeter. And the sheath of inside diameter 6 centimeter. So capital D is 6 centimeter. You need to calculate what is the maximum stress. Okay. And it is required to reduce the maximum stress by using two intersheets. So you need to have two intersheets. You have to find out what is their best position, that is D1 and D2. Okay, and he has given line voltage as 66 kilovolts. So you have to calculate what is the phase voltage. So phase voltage is VL by root 3. So what you have got is 38.1 kilovolts, but it is in RMS. You have to convert this into maximum value. So how do you convert? So multiply this by root 2. So what you will get is 53.88 kilovolts. This is the maximum stress, or you can say maximum voltage. Okay. Now, without the intersheath, the maximum stress will be G maximum. That is given by V2 by D by 2 natural log of D by D. This is without intersheath. So when you substitute the given data, what you will get is so D is 2.5. Okay, and you multiply this by 2. So this 2 goes go to the numerator. So what you will get is 2 into what is V, 53.88 kilovolts, right? 53.88 into 10 to 3, which is divided by 2.5. It's a small d, natural log of, and it is in centimeter. Convert this into meters. So it is just minus 2, natural log of capital D is D, 6 and 2.5. So finally what you will get is 4.924 into 10 to 6 volts per meter. So you convert this into kilovolts per centimeter. So finally what you will get is 49.24 kilovolts per centimeter. Okay. See, now two intersheets are to be used. Why? So as to reduce the stress. So let D1 and D2 be the diameters of the two intersheets, and V1 and V2 are the voltages at that intersheets. That is, V1 will be at D1 and V2 will be at D2 intersheets. Okay. The best position would be where the stress in all sections remain same. Remember this. The best position would be where the stress in all sections remains same, and which is possible only when D1 by D is equal to D2 by D1, which is equal to D by D2. Let us take this as a K. That is, D by D is, that is capital D by small d is K cube. See here. D1 by D. So you get this. So let us find what is K. Okay, K cube is equal to, so D by D. So finally what we will get is 1.33 is the value of K. Now, therefore, D1 by D will be K. Or, see here, what is that? D1 by D is K, na? Same. So D1 by D is equal to K, or D1 is equal to what? D of K into D. So that we will get is 3.347 centimeters. Similarly, we will get d2 also, d2 by d1 is k, and we have calculated the value of d1, so we can similarly calculate the value of d2. So d2 is equal to 4.48 centimeters. Okay. Now the voltages on the two sheets are V1 and V2. So V1 is equal to, we have derived this from in the previous classes. You can just check it out. So V1 is equal to V into 1 plus 1 by k divided by 1 plus 1 by k plus 1 by k square. Substitute the values. What is V? 53.88 kilovolts, and we know the value of k. So you substitute the value. Finally, what we will get is V1 is equal to 40.84 kilovolts. Okay. Similarly, for V2, V2 is equal to V divided by 1 plus 1 by k plus 1 by k square. So substitute the value. Finally, what we will get is 23.38 kilovolts. So the maximum stress with the intersheath is G1 max. Okay, and that is given by V minus V1. V is on your conductor surface. Okay, on the conductor. So V minus V1 divided by d by 2 natural log of d1 by d. So what we will get is, substitute the value, what we will get is 35.775 kilovolts per centimeter. This is the maximum stress on the first intersheath. Okay. So you can similarly we can find out what is the maximum stress on second intersheath also. Okay, you can do it. G2 is equal to V minus V2 divided by d by 2 natural log of capital D by d1 by 2. Here d1 by 2 natural log of capital D by d1. You substitute that, you will get some value. Okay, it's for your homework. Do it. So let us see one more problem. Here it's a typical problem. You can see that a 66 kilovolt single core lead sheathed cable is graded by using two dielectrics of relative permittivity 5 and 3 respectively, thickness of each being 1 centimeter. Thickness of each permittivity is being 1 centimeter. The core diameter is 2 centimeter. Determine the maximum stress in the two dielectrics. You have to calculate what is the G1 maximum and G2 maximum. So given data is, he has given the core diameter is 2 centimeter. I try to showcase you and try to represent the problem here. He has given the diameter of the core, that is 2 centimeter, but he has given the thickness. This thickness he has given. Thickness is 1 centimeter. So therefore this is 1 centimeter, this is 1 centimeter. So total diameter of the first dielectric from here to here is D1 is 4 centimeter. Similarly, this is also 1 centimeter, this is also 1 centimeter. And now total centimeter is 1 plus 1, 2 centimeter. And here it is 2. So what is the total? 2 plus 2 plus 2, 6 centimeters. So capital T is 6 centimeters. Fine. So he has given the working voltage V is equal to 66 kilovolts. It is an RMS. Convert this into maximum. So what I will get is 53.9 kilovolts maximum. He has given the permittivity, relative permittivities. Epsilon 1 is 5. Epsilon 2 is 3. Okay. We know that the maximum stress, that is G1 maximum, is given by V by D by 2 natural log of D1 by D plus epsilon 1 by epsilon 2 natural log of capital D by D1. We substitute the values here of V, D1, D, epsilon 1 and epsilon 2. See here, D is 2. This divided by 2 has gone up to the numerator, so 2 into 253.9. So the values, so what I will get is maximum stress on first dielectric is 39.38 kilovolts. That's what he has asked. See, you have to determine the maximum stress in two dielectrics. So the maximum stress in the first dielectric is 39.38 kilovolts per centimeter. Similarly, you can calculate G2 max. So G2 max is again V by D by 2 epsilon 2 by epsilon 1 natural log of D by D1 by small d plus natural log of capital D by D1. You substitute these values. So finally what you will get is the maximum stress on the second dielectric is G2 maximum, which is equal to 32.81 kilovolts per centimeter. So I appeal that you must solve more number of variety of problems. Okay, if you have any doubts, if you need any clarifications, I will be there. Okay, you ask me and I will help you to solve these problems. Okay, thank you.